Hello, welcome to my final year project video submission for my project network automation using Python. My name is Alex Banks and I've been working on the project. So the aims of this project were to demonstrate the efficiency of network automation, which was achieved through the literature review, where arguments have been presented for how efficient network automation is. Such as by saving engineers from spending time on the simpler tasks, such as just opening a port so someone can connect a PC, and which allows more time to be spent on dynamic tasks, such as creating ACLs, working with third parties on specific sites, and things that would typically be in for a single server, for example, in a data center. The next aim is to develop a working project which could be translated into real-world applications. The program has been developed and has been tested. It is working. The program was written in Python 3 and primarily uses SSH in order to connect to a device and push the config. And to make a clear comparison between the use of automation compared to doing the same task manually, arguments have been made throughout the dissertation, full final dissertation, using automation versus manual processes. As previously discussed, it's primarily around saving engineers time from the simpler tasks, but also, this will then directly save the business money. It will also prevent any typos from happening, because if the program does it correctly once, it will do it correctly a million times. The objectives of the project was primarily to develop a Python program which fulfills the aim of being a tool to perform a range of network administration tasks automatically. This was achieved, as we already discussed in the aim section. This has been a success, and I'm going to demonstrate this program in the next part of this presentation. The next objective is to evaluate the effectiveness of the program which was developed. It's achieved. Directly on paper, the main business benefit is saving of £19 an hour on average, according to the average UK network engineer salary. This is also assuming that one network engineer runs the program one at a time, rather than having two or three running at once. And it's based on how many times you run the program in a full hour versus manually doing the same process for the entirety of an hour. Next is to compare existing manual and automated processes to the new developed script. So an engineer can only perform one task at a time, and even when you're working on the single device at a time to perform one set of tasks, it can cause issues and typos, which would need to then be reviewed and come back to and cause problems. Existing automation tools I've used during my placement year. One of the main prominent one was BNA. This is a tool which will take backup copies of the network devices which are in its range that it's configured to see. Take a backup of the running config, the startup config, so you can roll back to it. This was also used to update the ACLs. So whenever a new ACL had to be pushed out across the over 600 sites, the BNA was heavily used to do this. The main negative to that is occasionally there would be issues with this, where, so for example, the ACL one would need to run 2 or 3 times in order to fully push the ACL out. And then finally, the identification of requirements of the program would be completed prior to starting the development process. This achieved, and this was done by writing some pseudocode at the start of the program, at the top of the Python file, which essentially bullet points what the goal of the program is going to be, and so it can be very easily referred back to during the development process. So the demonstration of the project is as follows. Open that up. Open PyCharm as well, actually. Yeah, so very quickly scrolling through the code. We've got the import top, our plan pseudocode here. Take a copy of the current date and time. And then the program will ask for an input file. Throughout testing, I've been making use of CSV file. In fact, this CSV file, to be specific. This is because project managers like to use Excel, and Excel documents can very easily be converted into a CSV. And then the program will open up the Ginger2 template, which that's the template that is used to generate the config, which is this here. It's essentially some Cisco config, interface config with a couple of if statements, well, ifs and elifs, and anything else. Just to decide, okay, what type of interface is this, right? What config needs to be pushed to the interface. And then the CSV file, which is defined above, is then opened using the CSV dict reader. And then for each row within that file, it's going to generate config using the template, Ginger2 template, saying that an interface in there is under the interface heading. The connected variable in the Ginger template is under the connected to heading. Link is link, purpose, VLAN, and then date time is the date and time from above. And then for each interface that it generates for, it will then append it to the generated configs variable. This lines 41 to 45 is setting up a dictionary for the device that's going to be connected to. So standard input for the device address typically be an IP address, but you can also choose a URL, a hostname address. Device type for purposes of development, I've been using Cisco Nexus OS. However, NetMiko has a very long list of devices, and so it can be set here. It can be set dynamically for an input if they're known, or you can statically set it within the program. Input the username for the user that's going to be connected to the device, whether this is on a per individual basis or if there's one static user set up on a local user on the boxes for performing these types of tasks. And then get pass is very similar to input, however it hides what the user's typed. So if someone's shoulder surfing, they can't read your passwords, for example. And then once the program has generated the configs, it will output it to a configs.txt. This is so you can then look back and say, okay, this is exactly what the program has generated before it's even attempted to connect to a device. The next piece is to take the generated configs and split it on each new line. This is simply down to NetMiko. When it's pushing config out, it likes to do it line by line. So rather than having a single string which contains, for example, 100 lines, it wants to have each of those 100 lines entered individually. So this is what's done here. It splits it into a config set, which is then used within the NetMiko connect handler. This is telling it use the information that we've just created in the device here. And then you can open NetMiko connect handler as connector. So in order to connect to the device, I'm going to print connected.find prompt. So this will print out the prompt, as we'll see. And then it's going to push the config out, the config set with the send config set command, and then save that to an output it'll disconnect from the device and then write the output to audit.txt, and then it will print to say, here is your audit.txt and this is how long it took. So, to demonstrate the actual program, I will where command prompt on there's command prompt. Simply Python single device.py, enter that. Input file is our switch underscore data.csv. The device that I'm using is hosted within Cisco DevNet and a Cisco Modeling Labs environment. This is down to just it being available 24/7, and I'm able to reserve for up to 5 days at a time. It then removed the need for me to create, or first of all, get licenses for my program, get licenses for the device which I wish to emulate, and then configure the devices from bare boxes. But yeah, I could use this and it was already pre-configured and able to be connected to, rather than having to set up routing, for example. So here we can see the program has connected to the switch. Just solely doing it on switch 1. It's just connecting now, so just have finished pushing out all the config, and that took 1 minute 17 seconds. And go back to the PowerPoint. So how is it applicable in industry? As already discussed, it's primarily going to be reducing costs. So rather than paying a network engineer full salary, you can, or paying 3 or 4 network engineers to do a single task, or to do a single task each, you can automate 3 of those 4 tasks, and then have the final engineer just run 3 programs to do those tasks, and then do their manual work. Which, obviously, if you're going to keep the same amount of engineers on, it's going to increase the available time for your engineers, which they could use for performing more complex tasks, for responding to incidents, for preparing new other changes, for doing, and then also for furthering their knowledge of network engineering, for instance, and going on doing additional training. And then consistent results. As has already been explained, this program, because if it uses the same template, the same input file, and the same device information, the end result, whether you run it 1 time, 1,000,000 times, it's always going to be the same end result. Whereas if it was an individual doing it, if one person was to type it 1,000,000 times, I can almost guarantee there's going to be some typos in there. So why this project and not another solution? Simplicity. A lot of modern devices now are starting to use APIs, but these are costly. So you've obviously going to have businesses which don't want to upgrade their routers to these new expensive boxes that have APIs in them. So that's why I've opted to use SSH, because if the device accepts an SSH connection, this program will work. And then it's less than 60 lines of code. So if there are any issues, it's very easy to try and find them, because there's only 6 lines of code. There's not a lot that can go wrong. So then the customization. So through the Ginger 2 templates, if you've got someone on your team that knows how to create a Ginger 2 template, you can customize this to do more or less whatever you want, as long as you have an understanding of what the templates can do and what template you want to use. You just need to create that template. And then low requirements. So many of the modules used are standard library, so not a lot needs to be installed additionally. It's very low CPU, very low CPU intensiveness. Probably not the right word, but yeah, it doesn't use much CPU power. So it's not really going to affect your day-to-day usage of your routers and switches that you're connecting to. It's just the equivalent of opening a session and manually sending the config. And so there's not a lot of specific training that needs to be done for this program. It comes down to, can the person open up the command prompt? Can they run a Python file? Do they know what the device credentials to log into the box? And that's more or less it. So thank you for listening to me talk for a while. And